Hello, we are going to be doing 5.3 notes today. So these are a little bit long, so I'm assuming it's probably going to take us probably 2 class periods to get through this. It may not take all of class period number 2, but you guys can break this up into 2 days, or you can do it all at once if you want, whatever you feel comfortable with. All right. So, looking at this, it says, look at the following ionic formula names and write down what you notice about them. So, I will give the students a few minutes here to look at them, read them out loud. Lithium nitride, sodium phosphide, potassium oxide. What do you notice about them? And I believe I've asked this in class before. And usually what the kids will come up with is that they all end in IDE. Okay, so we notice this. We notice that the first part of this name is just an element name. We don't change it at all. Lithium, sodium, potassium, that's just the normal name. But then the second half, we cut off the ending and add IDE to it. So here's the rules. This is how we're going to name ionic bonds. And remember, ionic is a metal and a non-metal. Okay, so what we're going to do is we're going to name the positive. Let me rewrite this. Name. I don't have it written on mine, but just in case you guys aren't sure, we're going to name the positive ion, which is your metal, first. So if you notice up above, lithium, sodium, and potassium, they're all on the left side of that stair step on your periodic table. They are a metal. So rule number 2 is you're going to name the negative ion, which is your non-metal, second. End in IDE. Alright? So you're going to name the first one. You're going to name the first one. You're going to name your positive one first, which is your metal. And you're going to name your second one, the negative ion, the non-metal, name it second, and you're going to end it in IDE. Okay, so just think positive first. Always think positively first, right? That's what we want to do. All right, so the learning check then. It wants us to name these things. So we're just looking at, is it positive or is it negative? If it's positive, nothing changes. So a +2, it's just going to stay barium. Aluminum is a positive, so it just stays aluminum. Nitrogen, though, look at that. That's a -3. So this is now, it's not nitrogen anymore. It is nitride. Nitride. So you see where we went nitrogen, got rid of that and added IDE. Oxygen, getting rid of that and adding IDE. So now this becomes oxide. So this is going to take some getting used to and just kind of some seeing it, being comfortable with it, becoming familiar with it, to know what these are. Because how do we know it's not oxide or something like that? It's oxide. So potassium is a positive, so it just stays potassium. And finally, fluorine has a negative sign, so it is now not fluorine, but it is fluoride. So instead of fluorine, fluoride. So like you can see where, okay, we got rid of OGN, here we got rid of YGEN, and here it's just that NE. All right, so it's just going to take some getting used to. So oxide, fluoride, we had nitride. All right, all based off if it's positive or negative. All right, now combine a metal and a non-metal from above and name it. So this is up to you guys. I'm just going to pick some. Remember, opposites attract, so it has to be a positive and a negative. We can't put 2 negatives together because their valence electrons won't work out, and they will not be happy with complete outer shells and stable. So it has to be a positive and a negative because of that. So I'm going to pick barium and nitrogen, and I'm going to name it barium. Because it's positive, we don't change that name. Nitride. Now you guys could pick out different ones, aluminum nitride, whatever you want. All right, so common rules for naming ionic compounds. Let's look at this. We're going to name the positive as the element, which we just saw. We've already kind of done this. Name the positive ion, which is called a cation. If you remember that chemistry with dogs, they mentioned that. Name the positive ion, the cation, as the element. Right? We did that. Barium is just barium. We named it as the element. The second one is name the negative ion, which is called an anion, by changing the ending to IDE. And then lastly, number 3, you're always going to name the cation first, which is your positive one, and your anion, your negative one, second. Okay, so it's pretty simple. Just name your positive one first, name your negative one last, change the ending to IDE of your negative. So let's look at the learning check here. Write the formulas and names for compounds of the following. So I've got my positive and my negative. It's almost like a Punnett square that we did last year. I'm going to bring over and down. So what I have here is I have Na, that's a plus, and I have nitrogen, that's a 3. So remember that crisscross, or trying to get these charges to equal out, it's going to be Na3N. Now let's name it. I'm going to name my positive first, so sodium, and then my negative one last, nitride. All right, now let's do sodium and bromine. That's a +1 and a -1, so it already cancels out charges. And this would be sodium bromide. If you want to try these right now by yourself, pause me, try them out, and then go back and listen and make sure you got them right. Or you don't even have to listen, just kind of fast forward to see what I have written down. Okay, we have Na, that's a +1, sulfur, that's a -2, so it is Na2S, and this is sodium sulfide. All right, and then finally, we have aluminum. So look at this, Al is a +3, nitrogen's a -3, so it's just going to be Aln because their charges already cancel out, and it is aluminum nitride. This one is going to be AlBr3 to get those charges to cancel, and it is aluminum bromide. And lastly, this is going to, if you flip-flop these charges here, it's going to be Al2S3, and that is aluminum sulfide. So real quick, if you're not sure how I did that, I'm going to write this out up here. So let's do that last one. Aluminum is a +3, sulfur is a -2. Trying to get these charges to cancel out. So right now, I have more positives than negatives. So I'm going to add a negative. So now I have a -4 and a +3. So I'm going to add some more positive. So right now I've got a +6 and a -4. So I'm going to add another sulfur. So right now my total charge is a -6, and that is a +6. I don't do that every time. It's just easier to crisscross those charges and not worry about it. It works out every time. All right. You can simplify though, and maybe, I don't know if we'll see one here. Oh yeah, we will. We'll see one here in a second. I'll talk about the simplifying. Okay, so let's do the next learning check. Write the names of the following compounds. So I have CaO. Now if you notice, if I have calcium, which is a +2, and oxygen is a -2, then look, if I were to crisscross these, it would be Ca2O2. But you don't do that. You can simplify that. You can divide by 2 on each one, and it's just CaO. So that's where they got that from. But let's name these. Remember, the positive one is always listed first. So Ca is my positive. It's calcium. And then oxide. Number 2, I'm going to name potassium just as potassium. And then bromine, I'm going to end with IDE, bromide. Number 3, I'm going to name aluminum like it looks. And then O, oxygen, I'm going to change to oxide. And number 4, I'm going to name magnesium just like it looks. And instead of chlorine, it's going to now be chloride. All right. So now, the next thing I'm going to ask them, and this might be a good stopping point for you guys, if you want to just fill out this part of the notes and then come back tomorrow and pick up right here where you left off. That's fine, or like I said, you can just continue on because we're going to get into something a little bit different here, and this might be where I stop with the class too and maybe give them, have them work on part of the worksheet, come back tomorrow, pick up here, and then work on the other part of the worksheet. So using what we've just learned, write the formula for a compound containing copper and oxygen. So let's do copper, and we have oxygen. Now up here, it's all about charges. So oxygen's a -2, I know that one off the top of my head, but look for copper. Go to your periodic table and look for copper. If you notice, copper is in the middle, it is a transition metal, and it does not have a charge. So you can see what the problem is. The problem is that copper has no charge, and usually kids will figure that out right away. So we don't know. Is it going to gain? Is it going to lose? If it does, how many? We don't know. So let's go down here to this right here. Now find copper on here. Here's copper. It can be a +1 or a +2. It depends. It can be either or. And there's a bunch of them up here like this. What I will have the kids do is, for example, zinc is also in the transition metals, and it is always a +2 though. There's no other option for it. It's always a +2, so I'll have them get their periodic table out and write a +2 in zinc's box, not above the column, because it's just zinc that does that. But you can see where, okay, all of these have multiple options here. So how do I know which one's which? And look at this chart. How do I know if I'm dealing with chromium 2 or chromium 3? If I just write chromium. And the answer is that you cannot just write chromium. You have to give me a Roman numeral. You have to tell me, hey, it's chromium 2, or you have to tell me, hey, it's chromium 3. And I'll tell you how we figure that out too. So even after showing you the charges for copper, what is the problem? So I showed you that copper can be a +1 or a +2. So here I go. I'm like, okay, awesome, -2. And then I'm like, ooh, do I use a +1 or do I use a +2 here? Well, in the previous problem, well, it didn't even tell us. It didn't tell us, it just said copper and oxygen. So I don't know, maybe it's CuO, or is it Cu2O? It depends if this is a +2 or if this is a +1. So I still don't know how to do that. So this is how we fix that, using those Roman numerals like I was just talking to you guys about. All right? See if you can figure out the name for iron chloride, because look, iron is in the middle. It's on this. Iron can be a +2 or a +3, but which one is it? Is it +2 or is it a +3? Now remember, charges have to cancel out. I'm telling you right now that that is FeCl2. Charges, this has to equal 0 on its charge, okay? So, this is what I do. I know I have 2 chlorines, right? They're each -1. So that is a -2 charge altogether. I have 1 iron. It has to be a +2. Okay, so this, normally I would name this and I'd say, oh, the name, I'm going to name my +1 first, iron, and I'm going to name my -1 second. But now, I don't know what iron's charge is. I had to figure it out, and I have to tell you that. If I don't tell you that, then what happened to copper and oxygen? We won't know which one. So you have to tell me the Roman numeral so I know what the charge is. All right? If you have a transition metal without a Roman numeral by it, and it can have multiple charges, we assume that it means 1. So I'm talking about, let me get rid of this and scroll up. Let's look up here. gold, for example. If I just have like gold nitride and I don't have a Roman numeral, you're going to assume that it is gold 1, right? So that's how that would work. All right, so let's name this one. Let's name this guy, because I know chromium. Let's look at this chart again. Chromium can be a +2 or a +3. So I cannot just write chromium oxide, because if I gave you a problem and gave you chromium oxide and I was like, give me the formula for chromium oxide, you wouldn't be able to. You'd be like, I don't know. I'm assuming it's a 1 because you didn't put a Roman numeral, because I can't go into my periodic table and figure out what chromium is. So oxygen is a -2. We're always going to use the one that we know. So let's look at this. There are 3 oxygens. Each oxygen is a -2, so that is a -6 charge altogether. Now look, we have 2 chromiums. So what does chromium have to be to have a +6 total charge? Well, it has to be a +3. Now look, this is +6. So this is chromium 3 oxide. Now this will take some practice. We will have to practice with these because this tends to be what gets kids the most during this section. All right, let's do some learning checks here. All right, select the correct name for each. So Fe2S3, so this is iron sulfide, I know that, but if you look at your periodic table, it is in the transition metals, so I need to know what kind of iron. Well, I'm gonna use the one that I know to figure it out. So sulfur's a -2, there's 3 of them. That means that is -6, right? There's 3 sulfurs, each one is a -2, so that adds up to -6. I have 2 irons, and I need a charge that would get them to be +6, and they have to be the same. I can't have like a +2 and a +4. Okay, so this should be a +3. So it is iron 3 sulfide. All right, now B is copper oxide. You go to name this thing, you're like copper oxide, and you need to take a second and be like, oh, copper is in the transition metal area. And if you're not sure, if you don't have those kind of memorized or know them by name, you need to look at your periodic table and make sure that if you see copper and you're like, oh, I can't remember, is that a transition metal? Then look. Because if it is, then you're going to have to do this. All right, so copper oxide. Well, I know oxygen's a -2, so there's only 1 copper. That means it has to be a 2, copper 2 oxide. That Roman numeral is telling you the charge. I fight with students every year because they see that Roman numeral 2 and they want to tell me that this means Cu2O, and it does not mean that. It means that it has a +2 charge. It is not telling you you have 2 coppers, and I have kids want to do that all the time, and I get it. I get it. It's really easy to want to do that. All right. Let's look at writing formulas. Maybe. Writing formulas. Here we're at our tail end. All right. So write the formula for potassium sulfide. So first identify the cation, and the cation is the first one written. It's always the first one in the name. The anion is the negative one, always second in the name, and then balance the charges. So potassium has a +1, sulfur is a -2. Neither one of those are in the middle. They're not a transition metal. So now I'm going to crisscross these charges. So it is K2S1, or you just write the S. All right, now then we're going to write the formula for cobalt. Identify the cation. It is the first one. Now this is cobalt +3. That's what that is telling me. It's not telling me there's 3 of them. And the anion is the negative one that's always written second, chlorine. Balance the charges. So I've got CO +3 and chlorine -1. This is going to be COCl3. All right, the last learning check. The correct formula for each of the following is copper 1 nitride. So remember, this is not telling me that there's 1 copper. It's telling me the charge is +1. And nitrogen is a -3. So that is going to be Cu3N. And finally B, we have lead, which is a +4, And we have oxygen. Look at your periodic table, it's a -2. So what I get is I get Pb2O4. This can simplify though. This can simplify into PbO2. So technically the right answer is A. Even though it looks like C should be the right answer, we're going to simplify. All right, guys, that was a lot. So let me know. That first worksheet is going to be participation. Let me know if there's anything you're not understanding. I will post a video of the worksheet, the answers of the worksheet, try to make sure that we're all on the same page here. But let me know if there's anything you need from me. Have a wonderful rest of your day, and I will see you later.